A warm good afternoon to all who have joined here for this webinar. As we all know, we have gathered here to celebrate the National Science Day 2021, organized by the Department of Science and Humanities, KCG College of Technology. In this webinar, we will be listening to a talk on mysteries of the universe, known or unknown. On this occasion, I'm here to welcome all of you who have joined for this webinar. First, I would like to welcome respected principal of KCG College of Technology, Dr. Devasundari. On behalf of KCG Science and Humanities Department faculty members and students, I welcome respected principal to this webinar. Welcome, ma'am. Along with that, I would like to welcome the chief guest of the day to deliver the main talk. Today we have with us Dr. Ebenezer Chellasamy Edwin. Currently, Dr. Ebenezer is heading the Solar Observatory Kodaikanal, owned and operated by the Indian Institute of Astrophysics. On behalf of KCG, Science and Humanities Department faculty members and students, I welcome Dr. Ebenezer Chellasamy Edwin to this webinar. Welcome, sir. Finally, I would like to welcome the head of the department, Science and Humanities, Srimati MP Bindu, to the webinar. Welcome, ma'am. And once again, I welcome all teachers and students who are participating in this webinar. This session will be starting with an introductory address by the principal. To deliver the introductory address, I welcome respected principal, Dr. Devasundari. Over to you, ma'am.
Thank you, Sharon. Good afternoon to all. Thank you to each and every one of you for being here with us today. Of course, Sharon has given in welcome, but I'm also very pleased to be able to welcome all those who have joined us today for this National Science Day program. Before we get started, I would like to express my sincere appreciation to the Department of Science and Humanities for organizing this program today. We know that India has a great heritage of science and technology from the ancient era. Many scientists, mathematicians, astronomers, and medical experts, to name a few, Aryabhatta, Brahmaputra, Nagarjuna, and much more, have contributed their work to the progression of science and technology in India. And in the 21st century, India is rapidly progressing to reach the peaks of the science and technology field in the world. And many Indian scientists have gathered global recognition by their work. And Indian physicist, we know him as Sir C.V. Raman, is one of them. Sir C.V. Raman invented the Raman effect, which studied the scattering of light in liquids, solids, and gases. And for his tremendous invention, he received the Nobel Prize for Physics in 1930. And to celebrate this success, our government of India decided to celebrate the 28th February as the National Science Day. And it was from the year 1999. That was the first year we celebrated the first National Science Day of India. With that note about the day, I also welcome our chairperson, Dr. Elizabeth Verghese, director and CEO, Dr. Anand Jacob Verghese, director, Dr. Annie Jacob, and other directors of Hindustan Group of Institutions who have been a great support always with every initiative every one of us come forth with. And to the chief guest, Dr. Ebenezer Chellasamy Edwin, who is the head Kodaikanal Solar Observatory, Indian Institute of Astrophysics. Sir, your address today will enlighten us, especially our students, and it's my pleasure again to welcome you for today's program. Of course, we celebrate the National Science Day to appreciate the efforts individuals and organizations who are working to make India reach the peaks of science and technology and make the lives of people better with the help of science and technology. But on this day, I feel personally it's very important that we pledge that we all of us will do our bit to make the science and technology better every coming day and we will use the technology to make the life of people simpler and not complicated. I don't want to take much of your time. Once again, a very warm welcome to each and every one of you. Thank you so much.
Thank you so much, ma'am. Thank you for reminding us the importance and the relevance of National Science Day. Next, we are going to listen to the main talk. Before listening to the main talk, it is important to know the chief guest of the day. To introduce the chief guest, I welcome Dr. Antal, Assistant Professor of Chemistry. Over to you, ma'am.
Good afternoon to one and all. Welcome to the webinar on Mysteries of Universe, Known or Unknown. I take this opportunity to welcome today's chief guest, Dr. Ebenezer Chellasamy, Head Kodaikanal Solar Observatory, Indian Institute of Astrophysics, and expert in astrophysics for this webinar today. He has completed his post-graduation from American College. Later on, he pursued his Master of Engineering from Indian Institute of Science, Bangalore. He has received his PhD in the area of solar radio astronomy from Mangalore University in the year 2010. For the past 3 years, he is working as the head of Kodaikanal Solar Observatory. He has more than 21 years of research experience and has published research papers in esteemed journals. He has taught courses on solar radio astronomy and guided several students for their project. His major research interests have been in the areas of solar radio astronomy, instrumentation, and astrophysical plasmas. Sir, it is our honor and privilege to have you with us today. I also welcome the participants. I'm sure we will be enriched by this webinar. Sir, now the session is open for you. Thank you, sir.
Thank you, everyone, for inviting me to be with you on National Science Day. It's really a privilege for me to be with you, especially the KCG College and the Department of Science and Humanities, the principal, the faculty members, and many other people and students. On a day, Sunday like this, coming for a webinar, it's not that easy. I know that. I will make enlighten you with the astronomical part here. And mysteries of the universe, known and unknown. It's the topic for us today. And I will bring greetings to you all from Kodaikanal Solar Observatory and all the staff of Indian Institute of Astrophysics, one of the premier institute in India. We bring greetings to you on this National Science Day. As Madam said, that is National Science Day is widely celebrated from the year 1999. To commemorate the great discovery of Sir C.V. Raman, and he has done tremendous work, and even still the work what he initiated is still going on. And Raman spectroscopy is part of a very big field now in the field of science and technology. And today's topic, I will be starting with the puzzles in the universe, very interestingly. Then I will be taking you through the evolution of the stars and the end state of the stars. And finally, the very interesting topic of black holes, which recently got a Nobel Prize. Okay, before that, I just wanted to take you a I would like to take you a virtual tour to Kodaikanal Solar Observatory. We have a long history for this place from the year 1786 when William Petrie came to India, and he established a telescope, and he established a building, and he established a small group of astronomers here, and he brought a telescope, and it is mounted here in the 1890s or so. Then the year from 1904, we have the record of the regular observations. This is a telescope, and it is being used for more than 150 years. And it is a equatorially mounted big telescope. And you can also see the nighttime vision with the next telescope we have here at Kodaikanal. And 1910, they have observed a Halley's Comet. And year 1986, again, the Halley's Comet, it's a short-term comet coming from the Woods cloud. It has been observed from the year 1986. We have a bigger telescope, 62 centimeter, 3-mirror system, and one of the biggest telescope in entire Asia Pacific region when they install. This telescope is being used in the spectroscopy to study about the spectral lines, especially the calcium K lines 3933. And the modern telescopes, like the very recent telescope, one is that you're seeing a big tube here, that is a observing tube. Another one is a guiding tube. This telescope been installed almost 5 years back. This is working at the wavelength of 65-63 angstrom, where the most abundant gas in the solar atmosphere is hydrogen. So the hydrogen spectrum can be seen on the lower chromosphere, can be observed with this telescope. This every day we update these pictures in our website. And another telescope is called the White Light Active Region Monitor Telescope. This telescope is also equatorially, this is a siderostat kind of the stuff, and it's all indigenously made telescope. The back end, you can see the two optics here, and we can see the hydrogen alpha along with that one white light, and G band we can observe here. And you may ask me, what is the use of all this stuff? Sun is not a common star. It is a very nearest star to us. And the sun, we could find the sunspots. There is a variations in the sunspot that was discovered in Kodaikanal. The radial flow of the gases in the umbra of the sunspot can be seen, and it is recorded here in the 1909. It was awarded a big award that is called the Evershed effect. It is discovered in Kodaikanal. You can see the variations in the sunspots at different wavelengths. You can see about white light, calcium K, and in a hydrogen alpha, you can see it look like a butterfly. It is called a butterfly diagram. This is one of the largest collection of scientific data in the entire world. This is about the sunspots. Okay, no, many other events have been all recorded, but this is one of the longest record we have in the face of Earth. Okay, and sun can be also seen in the radio wavelengths. We study it, and in our institute we sent another telescope, that is a space telescope, that is called AstroSat, launched by PSLV rockets of ISRO. It is giving a very fantastic images. You can compare these images with the galaxy image of NASA, and since it is recently launched, the quality of the images was far better than many other space telescopes. Okay, and a ground-based telescope, we have the biggest telescope very closer to you. You can also make a visit here. It is called Vainu Bapu telescope at Kavulur, very closer to Vaniyambadi, very nearer to Chennai also. And every Friday that is open for the public, you can visit here this telescope. The eclipsing, the picture of the Saturn is still illuminating. The disk of the Saturn is not continuous, and you can also see an invisible ring around the sun. These all the things yet to come in your textbooks also. Cassini is another satellite that has revealed much more new things, like till the year 2005, people have found approximately around 50 or 55 satellites for the Saturn. Now we have more than 82 satellites have been discovered, and most of them is less than 50 kilometers of radius. Okay, in the modern discoveries, people are very much involved, and they also got a Nobel Prize last year for the exoplanet study about exoplanets. You can see the potentially habitable exoplanets being displayed, and the array of discoveries has been displayed here with the Kepler satellites. It is very much, you can also see that you can Google it, planetary and habitable laboratory. There you can see about many things about the potentially habitable exoplanets. Okay, some people, they have reported in the Journal of Science that is it look like that the material is look like a diamond. They call that as a diamond planet also. So wider reported things are there. And let me take you to the Hubble Space Telescope. It revolutionized our idea, revolutionized our thought patterns, our idea about the entire universe. So if you take the deep sky view of the Hubble Space Telescope, you can see plenty of galaxies. We'll take all the information, see the stars, what you are seeing here. Most of them is all from our own Milky Way galaxy. Milky Way galaxy is one among the galaxies where we are living in. And if you count one star at a time, Sun is also a star, and one star at a time, you cannot count the stars in our own Milky Way galaxy in 10 minutes. You cannot count in 1 hour. You cannot count in 1 day. You cannot count in 10 days. You cannot count in 30 days. You cannot count in 1 month, and you cannot count in 6 months or 1 year, 10 year, 20 year, 100 year, 200 year, 30 year, 300 year, 500 year, 1000 year, 2000 years, 10,000 years. So our Milky Way galaxy having plenty of stars, 400 billions of stars. One star at a time, if you start counting, it will take almost 14,000 years it will take. That much stars we have. N.R. Parkson, he was a very interested person here. He worked as a director for this place, Kodaikanal Observatory. In the 1830 to 1860 to 1890, he classified almost 60,000 stars in our own Milky Way galaxy. I believe that is one of the early or one of the published work of our observatory in the entire Asia Pacific region. See, he classified 60,000 stars in our own Milky Way galaxy. Let me put everything together for you to make you to understand how big our universe is. Okay. I think all space satellites and ground-based satellite, if you put all these things together, then you can put, you can make a cube like this, what you're seeing here, and we call that is an observable universe. The universe is far, far bigger than this place also. Like if you look into the universe, it is far bigger than the observable universe. And let's take down and move, and if you take a small sugar cube from this observable universe and if you zoom it, you will be getting a local superclusters. You can see in the local supercluster, if you take a small speck and if you zoom it, you will be getting a Virgo supercluster. I think some of you are little familiar with our Virgo clusters, and if you take the Virgo cluster and if you zoom it, then you can see about our Milky Way galaxy. Then our nearest neighbor, our Andromeda galaxy is here. See, I am zooming it beyond a limit, then only you are seeing a Milky Way galaxy. Milky Way galaxy itself, if you take the width is, if you take a Milky Way galaxy, the rim of the Milky Way galaxy, we are almost 60,000 light years from us. See, 1977, September 15th, when the Voyager 2 started from Cape Canaveral in United States, it was going at the speed of 40,000 kilometers. Be with me, are you with me? 40,000 kilometer speed. It was started because that is a escape velocity. We all know that number. So now only it has gone little beyond our own solar system, like it has moved from our Pluto and little beyond. That we call that as a interstellar medium. It has just moved there. So it is nothing but it is 500 light minute, not even one day, not even light day. Light, what is passing for 1 year, we call it a light year. That is a unit we used in astronomy, and which is started by 1977. You just count it how many long years it has traveled. Almost 47 years of 50 years nearing. It has just gone to 500 light minutes, 40,000 kilometer speed. But our own Milky Way galaxy, we are from the center of from the Sagittarius here. If you can consider the width of the Milky Way galaxy itself, 100,000 light years. Are you with me? It is so big and so vast. The stars, whatever you are seeing, it's all most of them belonging to our own Milky Way galaxy. Okay, so our nearest neighbor, you know that one, and interstellar, our neighborhood, you can see all the other stars, and then comes our solar system, then our Earth. Okay, so now you understand how big our universe is. So when you take our own Milky Way galaxy, it's a part of Virgo clusters, it's a part of the superclusters, then it is a part of our own observable universe. The universe is far beyond or far bigger than your imagination. It's so big. How astronomers, we will measure? We use light years for our studies. If you wanted to study about the solar system, use sun-earth distance, that we call one astronomical unit, 1 AU. That is, it is approximately 8 minutes of light distance. Okay, 8 minutes is the distance from Earth to the sun. That is a distance, and we use that one, the call that is astronomical unit, AU. And for solar system studies, we use that one. And if you wanted to use for stellar studies, we have to use for light years, or we have to go for a parsecond. Parsecond is approximately 3.26 light years. The nearest star is Proxima Centauri. It is approximately 1.3 parsecs from our own solar system or sun. How old our universe is? So it is a big question. People are asking from the Big Bang and from the observation, we could derive the number 13 point, some people say 8, 13.6. So you can take some convenient number according to your own observations. Okay. How we know about how we estimate the age of the Earth or age of the universe? It is from the expansion what we can taken from the oldest stars in the universe. Okay. So everything must have some beginning, or when it's something has a beginning, it should also end. Today, I just wanted to take you through the mysteries of, or a very interesting part of the universe. That is, I am going to tell you about how everything has started. Okay, we call that is the starting point of our own solar system or from our universe is giant gas cloud. Okay, that is the way people believe that one, that is the starting point of our universe. Okay, and when you see that one, don't get confused with the nebula cloud or other clouds with the Woods cloud. Let you remember, I was telling you the sun earth distance is 1 astronomical unit, and Saturn is approximately 10 AAU, and 100 AAU, that is the sun earth distance is 1 AAU. 100 AAU, the whole stuff, that heliosphere, helio means sun, the heliosphere ends. Then it is in the logarithmic scale. You can see from 100 AU to 100,000 AU. That is a big area of cloud. We call this a Wood cloud. Wood is not discovered, but he proposed. Later days, the scientists have discovered and they have put his name for that one. And there only it starts the interstellar space. Interstellar means, stellar means, you understand the word, inter means in between. Okay, heliosphere ends here at 100 AU. Helio means sun, already I told you. So the nearest star you can see Alpha Centauri is here, then all our system is here. This is a scale I can make you to understand how big our own solar system is. Okay, don't get confused between the Mars and the Jupiter. We have an asteroid belt is there. This asteroid belt is different from the Wood cloud or Wood belt. Here only the comets are born. Okay, and where exactly the stars, whether stars are born today? Yes, the answer is yes. That we can, this for your reference, I have put a nebula taken from the Orion constellation. You can see some of the gas clouds, some of the blue color stars are early forming stars, and some of the stars are red in color. From the colors, we could detect their temperature. From there, we can calculate their age also. 1978, and these two gentlemen, Andrew Penzias and Robert Wilson, these two people, they discovered the universe is unanimously everywhere the same temperature. That is, we call this a cosmic microwave background radiation, or we call it CMB. And that was a foundation, or that was a building block to develop the Big Bang theory, and they got a Nobel Prize for that one. This is the telescope they have used, and it was in a microwave, and they shared the Nobel Prize with that one. They discovered there is a unanimously that they could find the variation in the temperature in the order of 0.001 Kelvin. To that level, they could be able to find it, and that was the cosmic microwave radiation. And most of you may be knowing about the Planck's radiation. And Planck's radiation can be found very much matching with the Big Bang universe, or we can model it very much. Okay, where the stars are born, and the stars are born in a place called nebula. And for your information, I would like to take you to the Crab Nebula. Crab Nebula is a very standard radio source also, and Crab Nebula is located almost 6523 light years, very, very far away from you. But even then, you can able to detect the pulsars, or pulsar is a central engine, is a pulsar is there. From there, even though it is 6523 light years, very, very far away from you, it emits a very strong radiation that can be detected in a radio wavelength. And the Butterfly Nebula, and that is also 3392 light years from you. You can see the blue color region that is a diffused. What is a nebula? Nebula is a cloud of dust, hydrogen and helium and other ionized gases out there. Okay, and from there the stars are born, and I skipped in between many stages, and I have come to the prototype of the stars, that is called the Alpha Centauri. That is our nearest star. You can compare the sun along with the Alpha Centauri, and you can compare with the Proxima Centauri. You can see the Proxima Centauri, the mass may be the same or to some extent, but it will be very, very compact. And Alpha Centauri, it's little bit bigger than us. Okay, and very interestingly, it has been classified with the luminosity. Luminosity is also, you can understand that it's a brightness also, with with also with a surface temperature. If you make a picture, then we can find it out different varieties of the stars, and there only you can classify the stars. And some of the stars will be mass will be very much more or very much higher than the solar mass. And solar mass is the mass, if you can take it as a reference of the sun. We in astronomy, we take sun mass as a reference, like 1 kilogram is on our standard practice what we have. Similar thing, we have the sun solar mass. It's 1 solar mass is the mass of that one. With respect to, we can tell a white dwarf mass, we can tell about a neutron star mass, we can tell about a supermassive black hole also, like 1 million times of the solar mass. All this kind of stuff we can define with the help of the solar mass, 1 solar mass. The weight of the sun is 1 solar mass. Okay, so the brightness or the surface temperature, the luminosity versus the temperature, if you plot it, that diagram is being done by Herschel-Sprung diagram, and you can see the main sequence of the stars. That is, our sun is also a mid-age star. It's not a protostar. It's a mid-age star, and it can live for another billions of years. And the main sequence is a continuous, distinctive band of stars that appears as a plots of the stellar color versus brightness. After the condensation and ignition of a star, it generates a thermal energy and a dense core region through the nuclear fusion of hydrogen into helium. And Hans Bethe, if you look into that one, he also got a Nobel Prize for his noble invention or a proposal of converting the carbon nitrogen cycle, CNO cycle, and the PP cycle. And how the helium is being converted into hydrogen, being converted into helium, the process, the neutrinos and the high energy being released. All these things were proposed by the Hans Bethe. Okay, we'll move on. Different varieties of the stars are there. Not all the stars are same. Like if you take the sun, it is approximately the outer temperature or the brightness, the surface temperature is 5,800 Kelvin. And if you go on, like the small red giant star, the temperature will be less. As the temperature is very, very less, the stars started bulging, or it will be, the mass may be the same, but it will be the size, it will be keep on going bigger and bigger. So if for your easy understanding, if the sun has died as a red giant, then it's more like it will keep on like a cotton candy. It will keep increasing in the size. Then it will touch Mercury, then Venus, even come to the planet Earth also. The temperature may not be that much higher, but it will be very much lower. Okay, now you got rough idea about different varieties of the stars. What is a red giant star? Red giant star is a dying star. It's not an early stages of the star. The last stages of the stellar evolution. It has been proposed by many scientists, leading scientists, including our Subramaniam Chandrasekhar. In only a billion years, it won't sun will turn into the red giant star, expand and engulf into the inner planets, possibly even to the Earth. Okay, I just given an example. And let me take you to the another varieties of star, that is called a white dwarf star. What is a white dwarf star? White dwarf means immediately your mind will go for Chandrasekhar limit. Yes, and the white dwarf star, the nearest companion star, it started accreting the matter. And the matter, when it is coming around and it will be keep on, it will be revolving around, that will produce the radiations. A white dwarf is what the stars look like, the sun becomes after they exhaust their nuclear fuel. Internally, there is two things are very much important for a star. One is about its gravity. Another one is the radiation potential. When the radiation exceeds, then the star started expanding and the gravity pulls everything intact. Therefore, these two things are balancing each other, and the star is in that equilibrium. And white dwarf stars, if the nuclear fuel is exhausted, then it started expanding and expanding. Then the size will go bigger and bigger, and the temperature will grow lower and lower. And there are many red giant stars have been discovered by the Kepler satellite, and you can also see here that is a different concept of the red giants. And Subramanian Chandrasekhar, you all should be very happy for him, and he discovered there is and he put a white dwarf that limit for that one. For that he got a Nobel Prize. A star that ends its nuclear burning lifetime with a mass greater than the Chandrasekhar limit, that otherwise we call it a 1.4 solar mass, must become either a neutron star or a black hole. And you can already explained about the red giant star companion with a white dwarf. Now you can see how it is matter is being accreted. This is all not imagination. It's all there in the universe. It is all real pictures. Okay, let me take you to the another varieties of star that is called supernova. 1987, people, some older people in this group may remember about the supernova. And supernova means that is the outer shell. If IN 54, if it happens, then if it is the nuclear shell is forming, further may not be possible. And the internal things, like when the shell is formed and internal, when the temperature keep on increasing, finally it will burst like anything. And a million megatons of materials will be thrown out into the entire space. That is called the explosion of the supernova remnant. It is all been observed. It is not an imagination. It has been theoretically predicted. Many calculations have been done, but it's also been observed. So supernova is an explosion or a large explosion in the space and end of the lifestyle of the star. And the matter after the explosion, the remaining materials may gather up, and that will form a neutron star. And Cassiopeia, we can see a giant Cassiopeia is also a supernova remnant. Occasionally, a star bigger than the sun will end up its life in a huge explosion that is called a supernova explosion. Okay, very interesting. This is the picture of the supernova. It has been used as a calibrator in any of our solar for solar people. We are doing multiple frequencies. It's been taken by the Chandra X-ray telescope by NASA. You can see the silicon, sulfur, calcium, iron, different wavelengths, and like high energy X-ray physics also. You can see about the supernova remnants. Okay. The use of the radio telescopes revolutionized our idea, our understanding of this universe. 1950s or 60s, it's all started, the radio astronomy started. People, earlier days, they were having only the visible light. That beyond that one, nothing was there. Even the gamma ray astronomy and the X-ray astronomy, all the things are very recent days of astronomy. But nowadays, it's very, very interesting to use this radio telescope. And Hubble Space Telescope, I've seen the largest and the farthest or the galaxy, almost 2.5 billion light years far away from us. And as I already told you about the neutron star, it is more like a rotating neutron star. Rotating, and the neutron star, we call it as a pulsar. Pulsar not is your bike or so. And Jocelyn Bell, with the picture what you are seeing about Jocelyn Bell, she discovered along with his thesis supervisor Anthony Hewish, and they found a chart, and there in a Cambridge, I think they were using the telescope in the University College in London, and they identified there was some kind of in an electronic circuit. If you are getting a small pulse or kicks, then we will doubt our own system, like our own instrumentation. But Anthony Hughes rightly pointed out to turn the telescope to some other direction. It was not coming. Again, the same direction, they found that some pulse is coming. Again, he disturbed, coming and not coming, not coming. And he identified it is a real one and it's not a fake. It's not an instrumentation problem. And he found and he proposed that one. And Anthony Hughes and Jocelyn Bell was not awarded a Nobel Prize, but she got a very good name in that one. And the later days, Chandrasekhar, our Radhakrishnan from Raman Research Institute, and he and along with Cook, they have modeled the neutron star. and still there's a very valid model for emitting radio emission coming from the neutron star. It's more like a lighthouse. When the beam comes towards you, you will be getting an emission rather than all the time. So the emission is not global. It's not all the time you will be receiving. It's more like it will be coming in terms of the pulses, radio pulses. Whenever it is the beam come towards you, then you will be getting an emission. Okay, so this is the picture. Let me take you to the, I already told you about the star forming regions and the planetary nebula. I showed you. Then I showed you about the prototype of the stars. Then I showed you about the big accretion disk and along with the stars. Then neutron star I showed you. Now I am going to tell you about the binary stars. Almost 80% of our universe filled with binary stars. So one will be rotating with other, and it will be having the central mass will be there. Along with that, one big star along with another star, maybe a companion of the white dwarf, maybe a red giant may be there. Like that, many stars. Even the two black holes also, they co-rotate with each other, and in the ripples of the space-time curvature, it gives you the gravitational waves also. It has been very recently discovered, and they got a Nobel Prize for that one. So these two binary systems, when they are co-rotating with each other, then the orbital period will be keep decreasing and decreasing. Finally, they will collapse with one another. Very interestingly, and in the space of the curvature of the space-time, that will produce a wave that can be detected, and they got a Nobel Prize for that one. The first detection of this wave happened in the year 2015, September, and two black holes as a binary system was co-rotating with each other. Let me show you again, and maybe very interestingly, look like, yes.
were locked in orbit and spiraling in towards each other. The only visible traces of this spinning cataclysm would have been the way their gravitational fields warped the light of distant stars.
Yes.
Even as they collided and merged, there wasn't a flicker of light to be seen.
Yes.
The real and very violent action in this system was in the form of gravitational waves, ripples in the very fabric of space and time. These waves were constantly draining energy from the black hole orbits, leading to their ultimate collision and merger to form a single black hole. At that instant, the power of the gravitational waves was 50 times greater than that of all the stars in the universe combined. That pulse of gravitational waves, lasting only a fraction of a second, expanded through the universe, passing unimpeded through countless galaxies. About 1.3 billion years later, it reached Earth. Gravitational waves alternately stretch and squeeze space itself and everything they pass through, but the effect is minuscule. Their effect on Earth here has been vastly exaggerated to help visualize something that is otherwise invisible on this scale. To detect them and directly measure their properties, scientists built LIGO, the most sensitive measuring device ever made. LIGO uses a device known as an interferometer to measure the tiny displacements in space. In this simplified representation, a laser beam is sent towards a partially reflecting mirror and split along two paths. The beams travel along the 4-kilometer arms and reflect back towards the central mirror, which recombines them, directing their light to a detector. As the gravitational waves pass, the distance between the central beam splitter and the end mirror stretches along one arm and compresses along the other. This changes the time it takes the light to travel along the arms. The recombined light waves shift with respect to one another and produce a signal at the detector. Incredibly tiny stretching and squeezing of space can actually be measured directly in this way. How little does space distort to make this signal? Let's zoom into a hydrogen atom until we reach the proton at its core. LIGO is so sensitive it can measure changes in distance as tiny as 1,000th the diameter of a proton. And this tiny measurement, made by LIGO, was the final step in a journey that began 1.3 billion years ago in the distant universe when two black holes collided.
I hope you enjoyed this one. Like Michelson interferometer has been used to the arms. It's in a vacuum of 4 kilometers either side, and at the 2 different places in the United States recorded the collision of the 2 black holes happened at the millions of years ago, and that you can measure very precisely. Like you can zoom to the higher order of the proton of the hydrogen atom. There, the 1,000th of the diameter of the proton of the hydrogen atom can be measured with this instrument, and they proved to the world. And the second, it's not the first time they proved for the second time. So they, everybody was so inspired to see the collision of the 2 black holes. And very long ago, Stephen Hawking, most of you may be knowing about him, and he proposed there was a radiation which is coming from the black hole. It has not been verified. It's in a proposal state. And what so far I have talked to you about is a nebula, wherein which the star forming things are happening, and it goes to the dust cloud and a globule, and a prototype stars and a star like our sun is happening. It will be having a lot of planets will be forming here. Then it will end up also, the prototype star end up as a brown dwarf, and it will be entering into the main sequence of the stars. Then if nuclear fuel is exhausted, then it will go end up in a white dwarf or a red giant, and it will also die as a supernova. Then the neutron star will be formed at the core of the neutron thing. Then it may, for the supermassive, it is a more massive things. After the star end stage, it may end up as a black hole. I think this is a rough picture, like it's a big course of its own, but I condensed for your easy understanding to this level. It has been gravitation waves. It has been proposed very long ago in the year 1915 by Albert Einstein. But the size of the black holes, it is almost 22 million kilometers. Such a supermassive or million times of the mass of the sun, it is been recorded very recently. Almost more than 12 years of continuous working by the 2 groups, and they proved this one. And it has been proposed in the 18th century itself by John Mitchell. And these 2 young people, along with Roger Penrose, who derived a lot of things for this one, they got a Nobel Prize for that one. It has been Sir Arthur Eddington that makes people say that one, the man who made Albert Einstein great or a remarkable person. He proved to the world to the solar eclipse experiment happened at crossing through the Brazil and Chile, and via the African coast also. He sent a 2 group of peoples to prove that one, the light from the external stars have been bent by the sun. And he proved to the world, and people started believing about the special theory of the relativity. There's a German person, and he was started solving the equations of Einstein, and he derived at the singularity. Let me explain the singularity a little later. And during the World War I time, and he proposed there is independently spherical object and curvature in the space and time. He called that is a black hole, and he solved this equation, and he found it is singularity at the center of the sphere and even at the edges also, like the rim. And nowadays we call that as a radius. The solution of the Einstein equation, according to Schwarzschild, and that we call it the Schwarzschild radius. The singularity is the, for your easy understanding, I can tell you about singularity is nothing but a huge mass concentrated at a very small or a tiny region. And at the center of the black hole, we call that as a singularity. Even the light, when it goes point of no return, it won't return back. And you are seeing Roger Penrose along with Stephen Hawking, and it is also that is being solved by an Indian, and his name is Amal Kumar Rai Chaudhary, and with a famous Russian's Landau equation he solved that they call as trapped surfaces. And already I explained you about the singularity, wherein which is the point of no return, even the light cannot escape from that one. All these things I told you about the evolution of the stars and the discovery of the black hole in the Milky Way center. It is being discussed in the Science Divide paper, okay? And the gravitational collapse, you remember the super dense material, and it is also been proved by the radio astronomers in the year 1974. You can also note down this web link I have given, public.nravo.edu. NRAO is National Radio Astronomical Observatory. It is located at the New Socorro in the United States. They give the lavish grants for the students to go and participate in their summer school or winter school, all this stuff. And you can take the recommendation from your professors, and you can also visit the United States and get trained in the NRAO. It's a very big facility. Similar facility is also in the meter waves we have at Pune, that is called a GMRT. And giant meter wave radio telescopes. Okay, so 1970 they have suggested, and these two gentlemen, Bruce and Robert Brown, they have discovered that's the center of our Milky Way galaxy, Sagittarius A. They have identified as a supermassive black hole. And these two people, Reinhard Genzel and Andrea Ghez, from the year, she's from the Max Planck Institute. They used the Chile telescope as well as the California Institute of Technology. They call Caltech, and they used the infrared telescope to calculate about the path or the eclipsing orbit of the black hole. And for their discovery, these two people, along with Roger Penrose, they got a Nobel Prize for that one. I think plenty of things to learn from astronomy, and every single thing is very exciting. And this is my contact number and my details. And so thankful to you all for listening to this lecture on National Science Day. Thank you once again.
Thank you so much, sir. Thank you so much for opening the universe of mysteries for us. Now, the floor is open for questions. Participants can leave your questions in the chat box, so that let us take another 2 minutes to clear our doubts. Yeah.
Good afternoon,
so
sir.
far,
There are already 2 questions in the question Q&A.
Due to what the Big Bang last? Big Bang, there are many theories are there. One among that one is a very almost popularly accepted stuff is about our Big Bang universe. And Big Bang is not a blast or kind of the stuff. It is the event. It's in a time scale. People calculate 10 power minus 40 seconds or something, how the material was there, then how the expansion happened. The expansion of the universe has been proved, that most of you must be knowing, and that is the building block. That is the Hubble expansion rate has been very precisely been measured. And Andrew Penzias, as you know, that I was explaining about, and they proved to the world that is the universe is expanding. From you can put everything to in a condensed fashion, and then you can find it out the starting point of our Big Bang universe. Let me go to the next question, sir. What is the center of our Milky Way galaxy and around our galaxy revolves? That is a black hole. Supermassive black hole is there in the center of our own galaxy. That has been predicted very long ago, but making a picture by the Event Horizon Telescope was being done in the recent days, and they got a Nobel Prize. Let me go to the third question. Does the theory connect the evolution theory of humans and living organisms? Does the theory connect? It's a very debatable theory. Many people have lot of missing links are there. It is not a very clear picture, so people are trying to find it out. Evolution theory, evolution is happening, and we need to accept that evolution. And whether humans are evolved species, and science is still giving a lot of evidence for that one. And the human genome project is going on, and scientists have the good understanding about the evolution now. Okay, sir, tell me something about a black hole endpoint star. I think it is a big story itself. Black hole itself, a big 1 hour lecture I can give sometime. Maybe if you're interested, I'll give you the link also. And very recent days, Professor G. Srinivasan has given that about a black hole and its theory. Professor Vishweshwara, whom I know him from the Raman Research Institute, and he has given he's no more, but he has given, we call him as a black hole man of India. And he has given a lot of public lectures in the YouTube. You can also see very humorously he has explained many things. Okay, is there other universe like a multiverse, or it's a rumor? There are like a Big Bang. People believe that one. It is multiple kind of the things are also being proposed, like a expanding universe. See, expanding universe means when you are thinking that one, it expands from one point or something. Then you can put a finger point where it is started, the origin. It is not like that really. It needs a lot of understanding, special theory of relativity. If you study that one, you will understand all this stuff. Let me go to the other question. A lot of questions are there. Matter can neither be created nor destroyed. Then how did the matter which is present now came into existence? No, it can transform from one to another, as you all know that one. That's what that early universe, if you take the Big Bang universe, in which we believe the matter was then in a super fluid state, and that matter was so dense. Now it is expanding, therefore the formation of the galaxies and all the stuff is happened. And it will take little time for you to understand even a neutron star. Neutron star, the size is only almost around 25 to 30 kilometers, that's all. But it is located almost 8,200 light years far away from you. Still you are getting a radiation. See, then you should know about that the mass is more massive than the mass of the sun. But the size is only 30 kilometers, 25 to 30 kilometers is the radius. So just imagine, and it will take little time for you. Then you need to understand about the theory of degeneracy and all the stuff. I am not going to that stuff now. Okay, let me try to, sir, what is inside a black hole? And it's a very, very tricky question. And what kind of the material may be about the black hole itself, you can Google it and you can find it out. And it won't be there like it's not a matter like what you are seeing here on the planet Earth. It will be the matter itself totally different. Okay, sir, what will have more age, black hole or stars? See, what the black hole, what will be the end of the black hole? And now the later stage of, as you seen the end state of the stars, I have finished as a black hole. Black hole will remain black hole, and after that it will give rise to a lot of matter. It will start accreting, and the matter will be also that's what Stephen Hawking, he predicted that the radiation will come out from that one. It will be very high energy or something. And some people are thinking about there is an emission. Still it is not been proved, but people like Stephen Hawking or something, they are believing that there will be an emission from the black hole. And does the black hole has an end? I don't think so. There is no end for that. Does that again, does galaxies collide? Yes, galaxies will collide with each other, like what I have shown you, the collision of the two black holes. It is been recorded, like galaxies will collide with each other. And is there an ending for formation of the stars? No, there's no end. As long as the dust and interstellar materials are there, stars are still born. Okay, what happens when the star goes to a black hole? That is the evolutionary stage of the star, which I explained to you now. I think very numerous questions. Even the physics people, they won't ask this many questions, and I am so happy. You're all having a lot of interest. I think I only kindled the interest. It's only a starting point. Even you are all there in the nebula cloud, so you have to evolve many more, and a lot of materials are still available. If you are free, feel free to contact me anytime. Okay, so if you are so interested, come to astronomy. And being the science stream, you can clear the CSR UGC exams or just examinations, and even the GATE examination, and you can join the astronomy group of astronomers. And a lot of still questions are coming out. I think we are crossing the time, I think. Am I right, madam? I don't know.
Yes, we'll try to post the questions and send it to you by mail so that we can get the answers from you, sir.
Okay, madam. You are most welcome.
Thank you so much, sir. Thank you so much for taking your time and clearing the doubts. Yeah. Now, We have come to the end of the session. Now it's time to thank each one of you who have gathered here. To deliver the word of thanks, I welcome Srimati M.S. Bindu, Head of the Department, Science and Humanities. Over to you, ma'am.
Thank you, Mr. Siren. Good afternoon, one and all. It is my immense pleasure to propose the vote of thanks for the day. I first express my heartfelt thanks to our management for their full support always in conducting such programs. On behalf of our college, I express our profound gratitude to Dr. Ebenezer Chellasamy Edwin, Head, Kodaikanal Solar Observatory, Indian Institute of Astrophysics, for having accepted our invitation and graced this occasion online. In a short span of time, you have tried to enlighten us with many points, sir. Thank you very much. I also thank our principal, Dr. Devasundari, and Dean of Student Affairs, Dr. Anita Manuel, for their constant encouragement. Thanks to all the HODs and faculty members, teaching and non-teaching, for your presence today. My sincere thanks to Mr. Pavan, Placement Officer, Mr. Nibin, IT Manager, and Mr. Suresh, KPB, for all their support in the arrangements for today's program. I conclude my vote of thanks by appreciating all the participants and my dear students for having attended the program today. Thank you, one and all.